Okay, so till now we discussed the sequential circuits flip-flop part. Flip-flop is all about sequential circuits, okay, but there are more things in sequential circuits are there. So today I'm gonna discuss about the last topic of flip-flop. Since till now we covered different types of flip-flop. We started from SR flip-flop. After that, for data storing purpose, we use D flip-flop. After that, we build JK flip-flop, and why we gonna build that flip-flop. We also discuss such kind of things in previous sessions. Okay. And also for that particular toggling condition, we also build a flip-flop named as T flip-flop. Okay. So today I am going to discuss about the last session. This is the last session of flip-flop sequential circuits in your coursework, semester 6 coursework, or anyone who want to learn flip-flop. So today I am going to mainly discuss about the flip-flop conversion. Suppose you have some flip-flop on your hand and someone told you to convert this flip-flop into other flip-flop. Okay. So we had some flip-flop and we will build some flip-flop, okay, using the available one. So how we will gonna build that? This is the things I am going to discuss in today's session. Okay. So to convert a flip-flop into another flip-flop, what are the steps to convert and how many steps are there? I am going to discuss it about elaborately. So I am requesting you guys, please hear these things clearly. Okay. So if the steps clearly legible to you all, then and understandable to you all, then you guys will solve every and not only solve, convert every flip-flop to another flip-flop quite easy way. Okay. So for that purpose, uh, what are the basic recapitulation you must have? For that purpose, you must have the clear idea about the different types of flip-flops, truth table, and from truth table is not only truth table, from truth table we build characteristics table. So you guys must have some idea about characteristics table, and also from characteristics table we build excitation table. So you must have the idea about excitation table of different types of flip-flops too. Okay, so without wasting any time, this recording is on. So let's proceed about the flip-flop conversion steps. Okay. Yes. So how many steps are there for flip-flop conversion? There are 5 steps are there that I am going to discuss it further to convert one flip-flop to another flip-flop. Okay. So what is the first step? The first step is we need to identify what flip-flop we had and what flip-flop we will build. Okay, so let's write it down using the phrase some kind of identifying the available and which need to build some flip-flop. Okay, so we have some available flip-flop we had and some required flip-flops. Okay, so first we need to identify what flip-flop we had and what flip-flop I need to build. Okay, that's it. The second point is that so we have already identified the available flip-flop and what flip-flop we need to build, that is the required flip-flop. Okay, so after identifying, we need to draw the do not draw, we need to write the characteristics table of the required flip-flop. Okay, so what's the second step? So I'm not gonna just telling you that. I will solve examples and also give you some assignments, and after attending this session I think the flip-flop conversion will not gonna cost you any headache and any trouble, okay, in future. So after that, what we need to do? We need to write the characteristics table of the required flip-flop. Okay, so what we had, we already identified the available one and required one. So the required one is already known to us all. Okay, so after that, what we must do, we must write the characteristics table of the required flip-flop. So what's the next is, this is the main and very important steps, and I said you please take care on that stage. So here we must make the excitation table for the available flip-flop. Okay, so what we did till now, we first identified the available flip-flop and required flip-flop. Okay, after that we write the characteristics table of the required flip-flop, because we already identified the flip-flop what we must be using the available one. And after that, after identifying and writing the characteristics table, we must write down the excitation table for the available flip-flop. Okay, this is the main important steps for flip-flop conversion. So till now, writing the characteristics and excitation table is done. So what is the, and this is also a easy, take care of the very important steps. And what we need to build now, simply some in previous sessions of characteristics table building and the excitation table building, we already discussed that through Karnaugh mapping we can easily evaluate the expression for JK case of the characteristics table, say excitation table. Excitation table where we also identify the expression for the input JK and also the present test next state, that is the characteristics table. And from characteristics table we also identify the expression for the next state through using the inputs and in terms of the inputs and the present state. Okay, so in fourth, what we need to build, we need to not build, we need to this is also identify or write, say, okay, or write the expression means what expression? The Boolean expression using the truth table, sorry, not truth table, Karnaugh mapping for the, so to write the expression, what write the expression what we had, we need to write the expression using what we had, not what we're gonna build. Okay, so this is a simple nomenclature you guys must remember for remembering purpose, since I'm quite remembering these things right kind of that way. So we write the expression for the available flip-flop. So if we available flip-flop, not only available flip-flop, available flip-flop in terms of the, in bracket you must write that in terms of the required flip-flops inputs. Okay, so this is the very important fourth steps. Okay, you must remember that step. And the final one, what the final one is, simply building. Okay, so to build that, what we need to draw a circuit. So let's build the required, so that is draw the circuit. Okay, so this is the steps. I think that steps are quite clear to you, and it will be clear more and completely clear after solving a example, right? So till now, if everything is clear, I'm proceeding with the next stages, and if you have any doubt, I request you to pause that part and recap the past 4-5 minutes of that session, and this will be clear to you. But don't worry, I am going to solve a problem, some easy problem. Okay. First I solve easy problem. After that a longer one, and I will give some assignments too for that purpose. Okay. So let's solve a problem about the flip of one person. So in the last session, what we discussed about the master slave JK. So in the last session we discussed about the JK flip flop. Okay. So let us consider an example where the available flip flop considered as JK flip flop, and from JK flip flop if we convert T is quite easy. So let's we build D flip flop using SR. So let's take an example. Okay, what example we can make? Convert that example. Let's write convert JK to D flip flop. Okay. So convert JK flip flop into or to D flip flop. This is the conversion that I am gonna solve it out to clear your doubts. Okay. And so what is the first step? First step we must identify the available and required flip flop. So let's solve it quite that way. Available flip flop is what? Available flip flop is what? Available flip flop is JK flip flop. And what is the required one? What? D flip flop. Okay, so available flip flop is JK flip flop and required flip flop is D flip flop. So what we had till now? We had till now the first step. So we obviously identified the available one, the required one that we are gonna build using the available one. Okay. So next step is we need to write the characteristics table of the required flip flop. So what will be our required flip flop? Our required flip flop is that we are gonna build D flip flop using JK. So required one is D flip flop. So and then henceforth we will gonna write the characteristics table using the is not using for D flip flop. So in case of D flip flop, the characteristic table is what? Characteristic table nothing but the present and next state table. Okay, that we are gonna build using group table. So I am gonna write it down here since I remembered that thing. So I request you guys don't remember that things. If you solve out many problems and write down the truth tables involved many times, it will be quite remembered to you and connected to you all. But I request you to draw the or write the characteristics table or present to next table first. Write the truth table, and after that using the truth table write the characteristics table, and after writing the characteristics table you may write the excitation table. This is the step. These are the quite simple steps that I taught you till now. So I requesting you to follow that steps. Okay. This is 0, 0, 1, 0, 1. Okay, this is Qn plus 1. So why I remember the characteristics table for D flip flop quite easily, because the thing is that the Qn plus 1 and D is equal in case of D flip flop for characteristics table. Okay. And if this is not clear to you, you may follow the previous sessions. So this is the present state, next state, or the characteristics table. Let's identify this thing as step 2. This is this on the step 1. So if any problem will come into your exams or anything, so let's write it down clearly, mentioning the steps on steps 2. This is the quite serialized or successive states that you first follow one by one. You can't write or anything. You can't keep or skip any step. Step that is you simply writing the after writing the steps one step 1 you simply write it the step 3. This is not a very sound-cooling point to you. Okay, so let's please avoid such kind of stuff or such kind of mistakes. So what is the step 3 then? Step 3 is what? Step 3 is here we for the record flip flop we draw the characteristics table. And in step 3 what we will do? We will gonna write the or build the excitation table for the flip flop that is available to us. So what flip flop is available? We have with the JK flip flop. So let's write down the next stage, and the inputs of, and this is nothing but the excitation table in case of JK flip-flop. Okay, let's extend this table. Okay, so yeah, that is not a problem to you all. This is the things I want to discuss is about little further. Extend this table. Okay. Yes. This is JK 0011 say 0101 say, and for that purpose, excitation table writing purpose, you must write the characteristic table in case of JK flip-flop first. So if you remember that, that is quite known to you, but you may verify it by writing the characteristic table. And before writing characteristic table, you may also write the truth table too. Okay. This is the things I wrote it there because I remember that thing. So I request you guys to do the same like I am doing it, because it will cause many problems and many mistakes in future. That's it. So what will happen here? Here 01 is there, and also in case this is the not allowed states. This is 01 means it is what 10, and it is also. This is the quite nomenclature that I am using to keep in mind the things, so you may follow the same thing. Okay. So now what we all do in the fourth step, what we write? We write the expression for the available flip-flop in terms of the required flip-flop inputs. Okay. So what flip-flop we require? We require the flip-flop D flip-flop. So in that table, we had the required flip-flops inputs D. Okay. So now we must write down the expressions for the what? The expression for the available flip-flop. What flip-flop is available? JK flip-flop is available. So we write down the expression for JK flip-flop using the required flip-flop input. What we will do? This is the very important step we must remember. Is we will simply extend this table in such extent that we will write the expression of JK flip-flop, that is our step number 4 say, using a truth table. Let's minimize it down so that we will be able to write down the step 4 in right side of my input. Say here, this is step 4 say. So here we write what? JK, because we need to find the expression of JK in terms of the input D. Okay, and not only the input D, also in such cases, here this is a single input flip-flop. In such cases, this is not the right nomenclature I write here. I write in terms of the required flip-flops input, not only input, there are outputs too. Okay, there are outputs too. The input means QN, and QN complements is there. There are some examples are there. I'm going to solve the example. After that example, in that case, what JK flip-flop is available flip-flops inputs expression. We will have the inputs and outputs of the required flip-flop. Okay. So here we will have the last stage. So in JK, so how we will complete that table? So we complete this JK in this fashion with using the QN and QN plus 1. Okay, so what generally we did here, we will do here, we generally write down the excitation table of JK with using that QN and QN plus 1. Okay, so you must say that this is the QN and QN plus, this is the same case. Okay, here QN is there, QN plus 1 is there. So you will gonna write that same table in that case. Okay, so in that case, the available flip-flops Q1 and Qn plus 2 inputs are there. Okay, so and the flip-flop that we must build, here there is only a single expression is there. Suppose we were to be told to build JK flip from JK to SR flip-flop. Okay, or any other flip-flop which have two inputs, then what we will have? We will have here 8 possible combinations. But in the excitation table, we have two possible combinations. So these things are not same. Okay, for that example, this is same. So that seems to you all that this is the things are quite same to you, and see this table is quite implemented here. For that example, this is occurring, but not in every example that will gonna occur. So you may solve it out, may verify my point that I recently told you what. Okay. So what we will gonna do? This is 0 0. So 0 0 is 0 not allowed. So same case 0 0. Consider this one and this one. Okay. So 0 0 is same case. So same case of what not allowed, not allowed. And this is 1 0. This is not allowed. Okay. So now what we will gonna build? We will gonna build the not build. We will gonna write the expression. Expression is a Boolean expression of the available flip-flop, that is JK flip-flop, with using the record flip-flops inputs and outputs. Okay, so let's JK, write the JK using the output and uses QN is the MSB, most significant bit. So let's keep it in the left side of the truth table. Sorry, not truth table. Right. Exactly this things with the Karnaugh Maps. So this is the T mapping say this T. So this is simple and quite easy to use. This is two variable and only four are there. 0 1 say 0 1 say. Okay. What will happen? This is for let's write these things, and this is for J say. Okay, and this is for K say. Same two tables are there. Oh, 0 1 0 1. Okay, so let's pair data. This is the first page. Only solitary pairs are there. So what we will have J equal to what? Q is changing, so we will gonna exclude it. And this is J equal to day. Simply easy. And in that case, what we will have K equal to, in this case Q is changing, so Q is also excluded there, and here TCT is 0, so D complement. So what we will have, this is the main important point. What we will have, we will have J equal to D and K equal to D complement. So this is the things that I need to build, and main step to build the required flip-flop using the available one. So now what stage? Now the final stage is step 5. In that case, we build the flip-flop. So so to build the flip-flop, what we will build, what we must do, we must draw the circuit. To draw the circuit, we first draw the circuit of the available one. So what flip-flop is available to us? So the flip-flop is JK. So simply draw the block diagram of JK flip-flop. You may, in the case of flip-flop conversion, no gate diagram is required. Simply draw the block diagram. Okay. This is the outputs. Say this is QN. This is QN complement. Okay. And the inputs are what? Inputs are simply J and K. Okay, J and K. And say triggered the flip-flop. So this triggered things is quite different that I discussed in master selective flip-flop. So H trigger different, or is level trigger. So this is the thing. So I say this is maybe H triggering. So I use that symbol. After that, what we must do, we must build D flip-flop using that flip-flop. So what we had J equal to D and K equal to D complement. So said here's the input for D flip-flop, D is there. So D is equal to J means we directly connected D through J. Okay. So now the question arises, what will be K? So this is plot C. Okay. So K is D complement. So some inverted kind of things are there. So to invert the input, what we will do, we must use an inverter. Okay. So to invert the input, D. After using the inverted part, we will have this D complement. So D is J and D complement is K. Okay. So this is the conversion of JK flip-flop to D flip-flop. So this is the D flip-flop converted circuit using JK flip-flop. So this was told to convert. Okay, so I think till now everything clear to you all, and if any doubts are there, you may ask it in comment section, or the contact number of me already provided everywhere. You may find it through Google link. Okay, you may Google my name and find the contact number, don't worry. So reach me out, I will try to help through WhatsApp or call. I will try to help. And if you comment it down for that video, since this video is really uploaded to you all in YouTube, I will try to answer in the comment section. So this is done. So let's solve out the another example, quite a large one. Say this is the example. Say let's change the color. So here we had the available as SR flip-flop. So convert SR flip-flop into JK flip-flops. So what are the steps are there? So what are the steps are there? Quite known to all. Okay. So you may pause that video and try it by yourself. Okay. So if there's any problems, do you have any sudden problems arises by solving them, you may continue the video and let's solve it and by using that video. Okay, but if you solve it successfully after pausing that video, then check it out at the extent of the video, at the end of the video, by skipping the parts of solving. So what is the first step? First step is quite known to you all. That is a step 1. Step 1 is level 1 is what? Level 1 is SR, and what we record? We record the JK. In step 2, what we do? In step 2, we must in step 2 you must what? You must first write the characteristics table. Characteristics table of what? Characteristics table of the flip-flop, the flip-flop that I need to build, right? Let's saw that. We need to write the characteristics table of the required flip-flop. I am right. So the flip-flop, what flip-flop we must build? If you are JK flip-flop, so we must write the characteristics table of JK flip-flop. So we keep it as extended. This is given +1. Here we keep it at extended, and 2 rows are there. What are the 2 rows? S and R. So why we keep it at extended, I also discussed some minutes before some minutes of that session. So if you forgot it, you may back the video and keep behind and watch it again. So what will be Q and +1? This is easy simply because 0 0 means key. What memory? This Q and so 0. This is what 0 1. So 0 1 is what? Also 0 0 0 0 0 0 1 0. Sorry. 0 0 0 0 1 0. 1 0 is 1. 1 1 is what? Toggle. 0 complement into 1s, and after that what? 0 0, that is memory QN, this is 1. 0 1 is 0 1 0 is 1. 1 is toggle at a QN complement, that is 1 complement, that's 0. So this is the characteristic characteristics of present test next step. So after that, what we will in step 3. The step 2 will be the excitation table of the available one. So what the flip-flop we have available? We have available with the SR flip-flop. So let's build the excitation table. SR flip-flop. We have 0 1 0 1. So SR flip-flop. So SR flip-flop characteristic table is what? I remember that things I write it down, but I request you guys first with the truth table, after that characteristic table, after that the excitation table. This is the process, step by step process to overcome any unnecessary and unexpected mistakes. So these are the things you must remember in exam purpose. You remember it quite confidently, like me, because this is the things I am doing it repeatedly, though this is quite known to me easily. So if you guys practice this in such way, so it will be quite remembered to you. Okay. You may verify it, and if any mistakes are there, you may tell me in comment section or by texting me on WhatsApp. So this is the thing. So here they see the example. Here what example? What we saw? This is only 4 combinations. This is 8 combinations. So using that to excitation table, we will build that excitation table using that output. That is the not output. We say is that is output is present state and also the available inputs. Okay. So 0 0 is 0 cross. So here we use that part. Use it with mark it with different color. We use that input and that input. Okay, to build that or to write down these things. Use this different color. So SR is what? So this is 0 0. This is also 0 0. So 0 0 is what? 0 not allowed. So let's write it down. 0 not allowed here. Okay. So after that, are the what hat 0 1 0. So 0 1 what 1 0. So 1 0 1 0. After that what 1 1 1 0. So 1 1 and 1 1 is what 1 1 is not allowed 0, and 1 0 is what 1 0 1 2 3 4 5. Also 3 we must write. 1 1 is what, and 1 0 is 1 0. So 1 0 is what 1 0 already is what 0 1. So let's write here 0 1. Okay. After that again 1 1 is there, that is not allowed 0. 1 1 is not allowed 0, and 1 0. 1 0 is this, so 0 1. Yeah. So we complete a table. It is we excited the what? We excited the available flip flop using the characteristics of the what? This is the main fundamental phrase we must use. We excited the available flip flop with using the available required flip flops, inputs and present state. So what is the next step? Next step we will the simply the truth table. Sorry, we will find the expression of the SRR in terms of Q and J and K. This is the step 4, not step 5. This is step 4. So here we wanna build the key mapping. So MSB is there. This is JK 0 0 0 1 1 1 1 0, and this is simply 0 1. So 0 0 1 1 0 0 1 1, not allowed 0, not allowed 0, not allowed 0, not allowed 0. So this is for is okay. So we'll find out the expression later. Let's write it for R same flip same not development of exaggerate this again and again. For R is not allowed, not allowed. 0 0 1 0 1. Oh, so let's pair it first. Here is the one solitary pair, and here this is for the one solitary pair. So what will be the expression? That is a Boolean expressions. So A is equal to what? A is equal to this pair. In this pair, Qn is Qn. Yeah. Here what we saw, here S is in terms of the present state, that is Qn complement, and here J is fixed, K is changing, so J is there. So Qn complement J is the S, and what will be the R? R is what? R is in that case Qn is there. So Qn and J is changing, but K is fixed. So Qn J. So this is the things that I need to draw the final state or draw the circuit. Okay, so now the step 5, the converted circuit. I need to draw. So what flip-flop we already have? We already have the SR flip-flop. So let's write down draw the circuit or block diagram of SR flip-flop. This is Qn, this is Qn complement. This is the negative HD card, say block is there. And this is say S, this is say R. So what is the expression of S? S is Qn complement J. This is Qn and Qn complement. So Qn complement is there and J. So in S what we have? We had the AND operated output of Qn complement and J. So here let's write the AND gate. Okay. And J is one of the input. Okay. So what is the other input? Qn complement? So let's extend this Qn complement here. So what we have? Qn complement J. So here is Qn complement J that we already found. And also NAND gate is there. The NAND gate first input is K. Okay, the second what is what? Qn. Let's extend it Qn here. So this is the converted JK flip-flop using SR flip-flop. Okay. So till now I discussed everything about flip-flop conversion in details with using two major examples. If you guys understand these two examples and hearing out the lecture clearly, so the next examples is quite familiar to you and easily solvable to you all too. Okay. So if there are any questions are there till now, you simply ask me in next session. Okay, next session is not there, this is the final session of your class, so you may ask in comment section or WhatsApp me or call me in any time after 12 noon. Okay. And you will call me at night, that is not a problem, is there. I'm not an early riser. I think this is the things you guys quite already familiar with till now. And so some assignments are there. Yeah, I'm giving you two simple assignments. So first convert T flip-flop into D. This is the conversion we need to do. T flip-flop is also you have available at T and D is the required one. And after that convert reverse conversion, you may carry converted JK flip-flop using SR flip-flop. But you may do the reverse things too, and this is the thing I want to tell you again. The first step is very useful because if you identify the available and the required one, vice versa, that is you simply roll to the available flip-flop as is for the above problem. You may roll the above available one is SR, sorry JK, and required one is JK. So this is the problem is completely changed. Okay. So these are the things you must take care a little bit. This is SR2 flip-flop also, and the third one also that you mentioned. Here you converted SR into JK, so you may do the reverse one JK to SR. So these are the things. So the once again I want to tell you one thing, that when we build the SR GK pickup using SR, we simply feedback that thing, that right. So same things we did it here. We simply feedback the output to the input of the SR pickup, that is JMT. So same things occurring here. So everything in flip flop and flip flop conversion quite relate with each other. Okay. So sequential circuits is why it's quite easy and very interesting. Okay, so this is not a very tough topic to remember. So many ones find it very difficult one and very such kind of things, and they neglected this topic. So this is not a very tough and topics are there. So I request you to visit that session quite sincerely. This is absolutely uploaded in YouTube, and if there are any doubts are there, you can ask it in the comment section or call me or WhatsApp me anytime. Okay. Thank you. So best of luck for your exam. Thank you and good night.